In this session, I'm going to consider exact solutions for integral equations. Exact solutions for integral equations is when the kernel of the integral equation is separable. Let's consider a second kind integral equation. Okay, this is our kernel, which is k of st. In the exact solution, we are going to say that if the kernel, this kernel is separable, that is g of s dot h of t, which means that the kernel is separated into a function of s and a function of t. If you multiply, you can easily get the kernel. Now, if our kernel is separable to what? G of s dot h of t. Now let's substitute this into our second kind equation. I'm going to have y of s to be equal to f of s plus lambda integral of a to what? B. Then in place of the kernel k of st, we're going to replace g of s dot h of t, y of t, then what? dt. The integral operator is respect to what? T. Therefore, g of s, the function of s, does not depend on this. So you can separate it. You can bring this one outside. So we're going to have y of s to be equal to f of s plus lambda g of s integral from a to b h of t y of t dt. So this is our resulting equation. Now let's represent this integral by c. That means c should be equal to integral from a to b h of t y of t dt. Now this side becomes y of s to be equal to f of s plus lambda g of s, then c. So this is the solution to this integral equation if we are able to compute this constant c. So to compute this constant c, let's come here. The c is equal to integral from a to b h of t y of t dt. Then since here is y of t, it's a variable of t, let's interchange the s to t. Then we're going to have y of t to be equal to f of t plus lambda g of t c. Now let's substitute this y of t into this c. Our c becomes integral from a to b h of t into bracket f of t plus lambda g of t c, then dt. Now let's expand this. I'm going to have our c to be equal to integral from a to what? B. This time this, I'm going to have h of t, then f of t plus lambda c h of t g of t all into bracket times what? dt. Now the c here becomes, we're going to have this integral from a to b h of t f of t, then dt plus, then you can bring the lambda c out because they are constant. integral from a to b h of t j of t dt. Now we are looking for c, so let's send this side to the other side. So we are going to have c minus lambda c integral from a to b h of t j of t dt, which is equal to integral from a to b h of t f of t dt. Now you can factorize c out. So our c to bracket 1 minus lambda integral from a to b h of t j of t dt to be equal to integral from a to b h of t f of t dt. We have to make this c the subject of the equation. Now let's divide both sides by this expression. C is equal to integral from a to b h of t f of t dt, all divided by 1 minus lambda integral from a to b and h of t g of t h of t g of t dt. So we are able to solve for our c. Now if we substitute this c into this equation, which is an unknown function, that becomes the solution to this integral equation. So the function becomes y of s to be equal to f of s plus lambda j of s integral from a to b h of t f of t dt, all divided by 1 minus lambda integral from a to b h of t j of t dt. So this is the exact solution for this integral equation. So whenever you are given an integral equation where the kernel is separable, you can apply this exact solution method to get the unknown function, to solve for the solution, to find for the solution to this integral equation. Now let's consider an example. So we have to solve this integral equation. We have to find the exact solution for this integral equation. First, if you are given this equation, you need to check the kernel k of st. Our kernel is giving us st, which is equal to s times t. So you can easily see that this kernel can be easily separated. You can separate it to two different functions which depend on only s, and the one that depends on only t. So you can have something like g of s dot g of h of t which means that this is a function of g of s, this is a function of only or t. That means they are separable. They can apply the method of what? The exact method to find for the exact solution. Now let's continue. I'm going to have y of s to be equal to minus. You can easily bring the function of what? The function that consists of only s out, because the integral does not depend on what? S, but depends on only t. Plus s squared. We now let c to be equal to this, because if you integrate this, you get a constant. So we now let c to be equal to this. So that you substitute the c into this equation. So our y of s become minus s c plus s squared. So this is a solution to this integral equation if we are able to solve for this constant. Now our constant is giving us c is equal to integral from 0 to 1 t y of t dt. Since you are having y of t here, let's interchange the s to t. So our y of t becomes minus t c plus t squared. Now let's substitute this y of t into this equation. So our c becomes c is equal to integral from 0 to what? 1 t into bracket minus tc plus t squared bracket close dt. Now our c is equal to integral from 0 to 1 t times t becomes minus t squared c plus t times t squared becomes t cubed all dt. So our c here becomes c will be equal to, if we integrate t squared, we're going to get minus t cubed c divided by 3 plus t cubed, we're going to get t raised to the power 4 divided by 4, all evaluated at 0 to 1. So our c becomes, c is equal to, wherever you see t, you replace it by 1. So we are going to have minus c over 3. That is 1 raised to the power 3 is the same as 1. Plus 1 over 4. So 1 raised to the power 4 is the same as 1 over 4. And 0 minus or minus 0, because wherever you place this 0 into this equation, you get 0 for the other side. So our c is equal to minus c over 3 plus 1 over 4. Now let's solve for the c. We are solving for the c. So let's send this term to the other side. We're going to get c plus c over 3 equal to 1 over 4. So let's find for the LCM for this side. We're going to have 3 here. So 1 going to 3 times. So 3 times c is what? 3c. 3 going to this 3, how many times? 1 times. And going to times this c plus c, which is equal to 1 over 4. 3 plus 3c plus 1c is 4c, which is equal to 3. So which is equal to 1 over 4. Now we are solving for c. c becomes 1 over 4 times 3 over 4. So our c becomes, this implies that c is equal to 3 over 16. So we have been able to solve for our c, and we are saying that this is the solution to this integral equation. If only we are able to solve for the c. And we are now we have our c to be 3/16. Now let's substitute our 3/16 into this equation. So our y of s is equal to minus 3/16 s plus s squared. And this is the solution to this integral equation. That is the exact solution to this integral equation by using the exact method. By checking, first checking that the kernel is separable. That means you can separate the kernel into two different functions which depends on only s and that depends on only t. Then substitute them into the equation and solve for what? The c. So this is the end of this